Hi, students. I'd like to explain the three things that came up in the questions, and those are recursion, modulo, and animation. So what I'm going to do is I'm going to go through three different lessons, one for each of those. Pay attention to where the mouse arrow is hovering, just that's going to be part of the explanation, and then we'll have the test. Now the test will be tomorrow. Um, you don't have to worry about it too much. What I mean by that is, I'm not going to test you directly on modulo or recursion. There will be some recursion involved, but I think you can get through most of that pretty easily. Um, so what I'm giving you today is just really an explanation of how things work. But of course, when you take the test, you'll be able to use whatever resources you need, and of course, copying and pasting as necessary. Okay, let's talk first about recursion. So this is our first example of recursion when we drew the tree, and what happens is that the function calls itself. All right, so I'm going to go through exactly what that means with this particular tree here. All right, so right now, notice that I'm hovering over line 4 and it says draw a branch W over 2 H 100 0. Well, W is the canvas width, which is 400. So W over 2 is 200. And H is the canvas height, which is 300. So the point 200, 300 is this point right here. Okay, so now look at where the mouse arrow is. The mouse arrow is pointing exactly to the spot W over 2H. All right, now 100 is the length. So if you go 100 pixels up, that shows you how tall this branch is. And you can see that looking at the canvas too. It's about 1/3 of the canvas. So that's 100 pixels. And then the direction is 0, which means straight up. Okay, so line 4 simply draws the trunk. Okay, now notice that in the definition of draw branch, which is lines 6 through 15, this is really the heart of the program. So the parameters are x and y. That's where the branch begins. L, which is the length, and direction. And direction of 0 would be straight up. We did that already. The other directions are going to be negative or positive, which means slanting left or slanting right. Okay, now var x2 here is x plus L times direction. Okay, so what we're talking about is where the line will end up. Okay, xy is where it begins, x2, y2 is where it ends. So we already said that the starting point, now look over to the mouse arrow, we already said the starting point is here. Okay, how do we know that the ending point is here, where I'm pointing now? Well, we know that because x plus L times direction would give you that W over 2. So remember the W over 2 is 300, or I'm sorry, W over 2 is 200. And so if you look at L times direction, well, direction is 0. And so that means my finishing point, I'm adding 0 to the starting point. So the finishing point x coordinate will be the same as the starting point x coordinate. Now let's look at line 8. Y2 equals y minus L. Remember that as the y coordinates get smaller, you go higher up on the canvas. And that's because the starting point is 0, 0 at the top left. So then what is my starting y coordinate? My starting y coordinate, and I'm pointing now, just follow the mouse arrow. That the starting y coordinate is right here. So that would be 300. The ending y coordinate is y minus L, which is 200, and 200 is up here. So we have a starting point and an ending point, and we can draw the line. So that's all line 9 does. It just draws a line. Okay. Now, we already said that the first line drawn is the trunk, which is true. But now look what happens. Okay, so what I'm highlighting, what I'm highlighting is the recursion. Okay, so follow closely as I trace how this program works. Okay, so in line 12, we're already in draw branch. The trunk has already been drawn, but it's getting called again. And here's an interesting thing. Notice that x2, y2 are those are those are the coordinates for the starting point of the next line we're going to draw. But those coordinates of the starting point are the same as the coordinates of the ending point. So where the trunk ends is where the first branch is going to begin. That's what we mean here. Now, how about L over 2? What does that mean? Well, that just means that the next branch drawn is going to be half the size of the last one. And so if the first one drawn, which was the trunk, was 100, then 100 divided by 2 is 50. So things just keep getting smaller. And then negative means that it points left. Okay, so follow my mouse arrow, and we're going to see how these are drawn in order. Okay, so let's take it from the top. I'm starting at the bottom, so I'm starting at the ground. And in line 6, I'm sorry, in line 4, when draw branch is called, okay, and then part of draw branch is draw line in line 9. When line 9 gets executed, I do all this drawing here, and the line ends there. Okay. Next, line 12. We are going to use that ending point as our new starting point. We're going to go for half of the length, so we're going to go 50, and we're going to go left. So that brings us, follow the mouse arrow, that brings us right here. Now, notice that draw branch called itself. And since it called itself, it circles back around to line 6 and it does that stuff. It executes the draw line, which is what we just saw. And then it goes to line 12 again, which means it calls itself again. And it chops the length in half again, but it's still going negative. And keep in mind, line 13 hasn't even been touched yet. Line 13 hasn't even been touched yet. And since the function keeps calling itself, it's like you have a function within a function within a function within a function, but it's just the same function. All right, so line 12 then, what's next? X2, Y2, so the new starting point equals the last ending point, L over 2, so we're chopping that in half again, and we're still going left. So when draw branch is called, and we jump back to line 6, and line 9 is executed, the following line is drawn. Watch the mouse arrow. From here to there. Notice that we keep going left. We keep going left because we haven't had a chance to go right yet. Okay, so then we do that. Line 9 is executed, and that brings us back to line 12, which means now it's going to loop back. It's going to loop back yet again. And so finishing point becomes starting point, x2, y2, L over 2, so that gets chopped in half again. And this will be the last time because now that it's been chopped in half again, it's no longer going to be less than 20 the next time. Okay, so we started with 100, then we went to 50, then we went to 25, and now we're at 12.5, and 12.5 is definitely not greater than 20, so this will be the last branch. Also notice though that we're only doing left branches still. Okay, so then draw branch gets called, line 9 or line 69 get executed, and then that execution of line 9 takes us from this point of the mouse arrow to that point of the mouse arrow. Okay, now you might be wondering, all right, well, what about all the right branches? Well, now that the left branches can't be drawn anymore, okay, and remember, we've got function within function within function within function, etc. Now it can kind of work from the inside out or from this point backwards. and take care of all those line 13s that weren't executed. Okay, so now that there can't be any more leftward branches drawn, okay, um, now each one of the right branches gets drawn because that's all it can do. Okay, so um, once line 12 can't advance anymore, that means that, of course, line 13 is the only thing that can be done since the minimum length of the left branches has already been reached. Okay, so the next thing that happens is line 13 of the innermost draw branch function is called. And when line 13 is called, we get this line here. Notice I start and mouse arrow moving, mouse arrow moving, mouse arrow moving, I end. Boom. That's a right branch. But now that right branch uh, has its minimum, which means now we're going to go back to the function before that was called, which didn't have a chance to do its right branch. And so that brings us to this point. Now, this point here, notice what it does. Okay, it goes right branch, follow the mouse arrow, right branch, follow the mouse arrow. But now it does have a chance to do a left branch because after that left branch, that minimum will be reached. And so line 12 gets executed to do this left branch. Watch it. Boom. And then since that left branch can no longer pass its minimum, line 13 is executed because that was left hanging before. And so that line is drawn from here, watch the mouse arrow, to here. Boom. Okay. Well, all of that was part of some right branching that was left hanging from before, left undone from before. And so then that brings us all the way back to this point. This point here is the first line 13 that was not executed. And it wasn't executed because line 12 got in the way first. But now that all of that's been exhausted on the left side, we now go to the right side. Okay, and so we go to the right side. We start here and we go to this spot here. Okay, but once we reach this spot, line 12, leftward lines always take precedence. And that's only because line 12 comes before line 13. And so now what will happen is we're going to do another leftward branch because we can. And so that goes from here to there. And now again, left always takes precedence because 12 comes before 13. And so now this branch will go from here to there. Okay, exhausted. Since that's exhausted, now we can do a line 13 that was left hanging. And so we do a right branch from here to there. And now that's exhausted. So we do another line 13 that was left hanging, and that's right here. So this one here goes from here to there. But now we have a chance for another left branch. Left branches always take precedence. That goes from here to there. And finally, our last line 13 that was left hanging will draw the branch from here to there. And the tree is finished. Okay, so that's how recursion works. Now, in the test, I'm not going to be asking you to re-explain everything I just explained. Um, and you can even use recursion on the test by copying and pasting. But I still want you to understand basically how recursion works. Okay, next, we're going to go to modulo. Okay, so let me just skip ahead. And we're going to skip ahead to that checkerboard stuff. All right, so here's some checkerboard stuff. Actually, I like this way of making a checkerboard better. I think it makes more sense. It doesn't use any modulo. Um, and probably some of you just figured out how to do this checkerboard. It's just using for loops. Okay, but let's um, let's go ahead and see how modulo does work. That starts here. It's um, it's a way that uses slightly less code. It's a way that I don't like as much. Um, you're also not going to be tested directly on it, but the only thing you really need to know is what that percent means. Okay, so let's talk about that just for a second. Percent means modulo. That means it gives the remainder after dividing. All right, so 4% 2 is 0 because 4 divided by 2 is 2 and the remainder is 0. Okay, 100% 98 is 2 because 100 divided by 98 is 1 and the remainder is 2. 50% 45 is 5 because 50 divided by 45 is 1, but the remainder is 5. Okay, so that's all it means. Don't get confused with the regular percent because even though the symbol is identical, it doesn't mean the same thing. Okay, now let's talk specifically about how this checkerboard program works. And the thing you might have been confused about is line 5, okay? If you look at line 5, you're like, hmm, well, all right, that's an if statement. But how can the condition be true or false? I mean, the condition in line 5 is just going to end up being a number, right? Well, yes, you are right. And unfortunately, code Maven here does not explain that very well. And what it comes down to is that in computer language, um, true and false also has numerical equivalents. In if statements, 0 is false, and anything but 0 is true. I'll say that again. In if statements, 0 is false, and anything but 0 is true. So what that means for lines 5 through 8 is that we will not get a black square if the condition is false. And what that equivalently means is if what's in parentheses in line 5 evaluates to 0, then that's considered false. And then lines 6 through 8 do not execute for that particular values or those particular values of I and j. All right, so going back to the checkerboard, then what does that mean? Okay, notice the 6 up here means we have 6 columns. The 4 down here means we have 4 rows. Okay, now notice the checkerboard pattern. Okay, so what I'm going to do is so pay attention again to the mouse arrow and where it's going. Pay attention to the mouse arrow, and I'm gonna look at some labels here. Okay, so remember in computer language, 6 is counted as 0, 1, 2, 3, 4, 5. So this would be column 0, column 1, column 2, column 3, column 4, column 5. Now how about the rows? The rows for 4 rows are counted 0 through 3. So row 0, row 1, row 2, row 3. Now let's look at the pattern of black and white. Okay, so notice that you're going to get black squares for, and I'm going to hover over each black square. Okay, so this black square here would be the square uh, 0, 1. Okay, why 0, 1? Well, it's in row 0, column 1. 0 is even, 1 is odd, there's a mismatch. Let's go to the next black square. Well, this is in row 0, column 3. 0 is even, 3 is odd. That's a mismatch, black square. Let's go to the next black square. Well, it's in row 0, column 5. 0 is even, 5 is odd. That's a mismatch, black square. And let's look at how this pattern keeps continuing. Okay, the one I'm hovering over now is row 1, column 0. 1 is odd, 0 is even. That's a mismatch, black square. Next. This is row 1, column 2. Row is odd, column's even. That's a mismatch, black square. Next. Row 1, column 4. 1 is odd, 4 is even. That's a mismatch, black square. And I'll just do a couple more. Look down here. Okay, this black square. Row is 2, column is 1. 2 is even, 1 is odd, mismatch, black square. And the last one, because then I think you got the point. This is row 2, and it's column 3. 2 is even, 3 is odd, mismatch, black square. Okay, so what that means is for the checkerboard, you'll get a black square when there's an odd even mismatch, but you'll get a white square when both are even or both are odd. Let's go through the white squares. Okay, let's go through this one here. Um, row 0, column 0, both even, therefore white square. Next, row 0, column 2, both even, white square. How about here? Row 0, column 4, both even, white square. How about this one down here? Well, you have row 1, column 1, both odd, white square. How about here? Row 1, column 3, both odd, white square. Okay, so that's the pattern, and that's what this particular method of coding the checkerboard uses. Okay, so let's go through what I'm highlighting right here to see how this works specifically. When what's purple evaluates to 0, that means that what you're going to have is both odd or both even. Let's look at an example of how that can be true. Okay, so let's look, for example, at, I don't know, let's pick this one right here. So for this one here, we have row 2, column 2, row 2, column 2. So that means I is 2 and uh, J is 2. Okay, so then we plug those in here. Well, 2% 2 means 2 modulo 2. Remainder is 0. 2% 2, 2 modulo 2, remainder is 0. So this means 0 plus 0. Now, 0 plus 0 is 0. And then you divide by 2, you get 0. And there is no remainder because you never have a remainder when it's just 0. That's just by definition. And so if this is 0, the whole thing is 0, which means the whole thing is false, and therefore lines 6 through 8 don't get executed. And that's why in this spot that I'm hovering over, the square that is in row 2, column 2, does not get drawn. See, the only things getting drawn in this code are the black squares. The white squares, nothing's getting drawn. They're just getting skipped. They're just getting skipped. Now, when this expression here in purple evaluates to something that's not 0, then it's considered true, and then lines 6 through 8 get executed. Okay, so let's look at an example of that. That means we're going to have to look at a black square. So let's do this black square right here. This black square right here would be, let's see, row 1, and it would be column 2. So row 1, column 2. That's a mismatch. 1 is odd, 2 is even. Let's see how that plays out in the condition here. Okay, so um, we have we have row. Okay, so the row, that's going to be J, and so that's 2 here. And then the column, let's see, the column. Oh, sorry, my bad. The column is 2, and the row is 1 for this particular one. Okay, columns 2, rows 1. Okay, so the column number then is going to be our I. So if we have 2 here, then 2% 2 is going to be 0. Okay, but then we have um, we have 1 here. Okay, and 1% 2 is going to be 1. So that means 1% 2, again, is going to be non-zero, which means that evaluates to true. And since it's true, 6 through 8 get executed, and we have a black square. Let's look at another one over here. This one down here. Okay, let's see. That would be row 3, column 4. Row 3, column 4. Okay, so that would mean I is 4 and J is 3. I is 4, J is 3. Okay, so 4 modulo 2 is 0, but 3 modulo 2 is 1, and 1 modulo 2 will be non-zero be, because it's going to be a fraction. And remember, anything but 0 is simply evaluates to true. Therefore, that square will be drawn. Okay, so again, um, this way of doing it is simpler as far as requires less code to write, but I think it's more complicated just because of the math involved. So so don't worry about it. You're definitely not going to be tested on it. All right, now we're going to go forward to some animation, and this this last thing is probably simpler than you might expect. Really, all that's happening here is you're getting an illusion of animation. Um, in fact, that's how all animation works, whether it's video games or cartoons or movies. Um, if you think about it, there's no such thing as true animation except in real life, because in those examples I just mentioned, it's always simply a series of still pictures. It's always a series of still pictures. If you see 30 still pictures per second, that's so fast that you have the clear impression of animation. That's what all animation is based on. So what's going on here is a square is drawn, then the whole canvas is erased. The whole canvas is erased. How do we know that? That we know that in line 15. Okay, so if I'm highlighting line 15 right now. Clear rect 00 WH. That means clear the rectangle that goes from 00, that's top left, I'm pointing at it, top left, 00, all the way to WH, that's bottom right, WH, bottom right. You erase that. So every time a square is drawn, the whole canvas is erased. And then a new square is drawn, and so on, giving you the impression of animation. All right, now, what about the time step? So take a look at this. It says step equals 50 in milliseconds. That means that every 50 milliseconds, um, a square is drawn. Every 50 milliseconds, the canvas is erased and square is drawn. You notice it's in that order. Line 15 is erase canvas. Line 17 is draw square. Erase canvas, draw square. Erase canvas, draw square. Over and over and over again. And that happens every 50 milliseconds. Now, computers are so fast that they can do tons of things in a short amount of time. So we don't perceive this as slow. Um, what if I changed it? Okay, so let's say I change this to 20. Okay, notice how much faster it is? It's so much faster because now it's happening every 20 milliseconds. Okay, so now I'll go back to 50. All right, how is the time delay affected? Well, it's always the same thing, and the whole time we're doing animation, which will be from now on really, you're going to see the same combination. You have a variable called CMTID, which is clear timeout, clear timeout ID. And then you'll always have something within the function, like line 23, clear timeout, which uses the variable. And clear timeout is a built-in command in JavaScript. It's a built-in command in JavaScript. The parameter of this command, you could call this command a function because really it's just a pre-written function that you get to use. It always has a parameter. That parameter was defined in line 10. And then this is where, right here in line 25, this is where the value of that parameter is set. And it's set with another another built-in function, the set timeout function. And set timeout function always just has the function name as one parameter, and then has the step value as another parameter. So literally, line 25 is saying this. Okay, line 25 is simply saying do the draw step function every 50 milliseconds. Okay, that is the translation of line 25. Do the draw step function every 50 milliseconds. That's all it is. All right. That's all it is. You don't have to worry about it. Um, Notice also a few other things here. Notice if we change VY, I can change VY to, let's change it to 8. Okay. What what that means is that now it's a lot steeper because the amount of vertical deviation or vertical difference is much greater than it was before. And it's greater than the amount of horizontal difference. So Vx is horizontal difference, Vy is vertical difference. And here in line 19 and 20, lines 19 and 20, all they're doing is they're just making sure that the square fits inside the canvas. Okay, because we want to make sure that whatever that x coordinate is, plus the difference in x coordinate, if we add size to it, we want to make sure that the entire square fits, and it has to be left of the canvas width, which is the right limit, and it has to be above the canvas height, which is the height limit. That's h. All right, so hopefully this video helps to clear up some of your questions. At this point, if you've done all the lessons and you've understood this video, you should be ready for the test. And I will give the test tomorrow. You can take it anytime during my class office hours. I've already mentioned what those are. But if that doesn't work out for you because of coordinating with the computer or anything else, you can just let me know and I'll be flexible and we'll figure out another time for you to take it. So don't worry about it. We're all in this together. Thanks for your patience so far. Um, and let's all pray for each other.